Hey guys, great to be back with you all again today. We're going to be talking about problem solving today. And we're going to be talking about a wide variety of skills, really. We're going to be talking about 3.4 A and K and 3.5 A and B. And that's problem solving with all operations, basically what it is. And the I can statements is I can choose the correct operation to solve a word problem, and I can use the correct strategies to solve to problem solve. So we're going to look at some of the vocabulary. Since we're using all operations, that would be addition, subtraction, multiplication, and division. Those are the four operations we use in math. And we have for addition, we have add in are the two numbers we put together to get our sum, which is our answer. And minuend and subtrahend and difference. Difference is the answer to a subtraction problem. There's a community property of addition. That means I can switch the numbers around and still get the same sum. That's not a fact with subtraction, though. There's specific order. We always start with a larger number in third grade and take away a smaller number from that to get a whole number or a positive number. Multiplication vocabulary. You know, it's factor, those two numbers we put together in our multiplication to get our product. And there's a community property of multiplication, which means we can switch numbers around. 5 times 4 is also 20. And division vocabulary, dividend, divisor, quotient. Quotient's the answer to a division problem. And we cannot switch around. I cannot say that 5 divided by 40 equals 8. That would not be a true statement. So there's a specific order way we divide things, just like subtraction. They're very similar. Have a few videos we're going to watch about these skills. We'll watch one of Aaron's videos talking about how to solve problems using different operations and stuff. So let's go ahead and get ready for those videos.
Hi, welcome to Math Antics. In this lesson, we're going to learn about an important concept in geometry called perimeter. Perimeter is just a fancy math term that means the distance or length around a shape. But what exactly does the distance around a shape mean? Well, distance or length is a one-dimensional quantity that we can measure with units like centimeters, inches, or miles. That means that perimeter is also a one-dimensional quantity that we can measure with units of length. For example, the perimeter of a shape wouldn't be just 10, but it could be 10 centimeters. Or instead of being just 25, it could be 25 miles. The units are really important when you're talking about perimeter. Okay, but what exactly do we mean by around a shape? Seems like there would be a lot of different ways to go around a shape. Some of them would be short, and some of them would be very long. Well, perimeter means the absolute shortest distance possible around a shape. That would be the distance you'd get if you trace the path exactly around the border or edge of a shape. A good way to see what perimeter is to imagine that you could walk right along the edge of a shape, like this 5-sided polygon. Imagine starting at one of the polygon's vertices and then walking along each side until you got all the way back to the point that you started from. The total distance you traveled would be the perimeter of that shape. In this case, if the length of each side of the polygon was 10 meters, the total length you would travel along all 5 sides would add up to 50 meters. Another good way to see what perimeter is to imagine that you could take a shape, like this square, and break it at one of its corners. Then you could unfold the shape until it formed a straight line. The length of that line is the perimeter of the shape. Doing this helps you understand why perimeter is a one-dimensional quantity, even though it applies to two-dimensional shapes like this square. It's one-dimensional because it's the distance of the lines that go around the two-dimensional shape. Okay, so now that you know what perimeter is, how do we measure or calculate it for different geometric shapes? Well, that depends on the shapes. Finding the perimeter of shapes that have curves, like circles or hearts or things like that, can be tricky. In fact, we'll wait and talk about the perimeter of a circle in another video. In this video, we're just going to focus on how to find the perimeter of polygons. Since polygons are made from only straight sides, it's easy to find their perimeter. If you know the length of each side, all you have to do is add them up and the total length you end up with is the perimeter of the polygon. Let's try doing that with a few examples so you see how it works. The first polygon we'll try is a triangle. This triangle has 3 sides that are each a different length: 3 centimeters, 4 centimeters, and 5 centimeters. Now, to find the perimeter of the triangle, all we have to do is add up the lengths of those 3 sides. 3 plus 4 plus 5 equals 12. But don't forget, it's not just 12, it's 12 centimeters. Always remember to also put down the units of the perimeter. Okay, that was easy. Let's try another one. This time our polygon is a rectangle, and you can see that the shorter sides are each 5 meters long, and the longer sides are each 10 meters long. So let's add them all up. We can add up the sides in any order we want to, as long as we don't forget any sides or accidentally count any of them twice. And I think I'll add up the 2 short sides first. 5 plus 5 equals 10. Next, I'll add up the 2 longer sides. 10 plus 10 equals 20. And now, if I add up those 2 answers, I'll get the total for all 4 sides. 10 plus 20 equals 30. So, the perimeter of this rectangle is 30 meters. You thought I was going to forget my units, didn't you? Not this time. Here's another good example. This is a 6-sided regular polygon. A regular polygon means that all its sides are exactly the same length. And that's good because this diagram only shows the length of one side, 4 centimeters. But since the polygon is regular, we know that all the other sides are also 4 centimeters long. Now, we could just add up all the sides like we did before, but since they're all the same, we can use multiplication as a shortcut. That's because multiplication is really just repeated addition. All we have to do is multiply the number of sides, 6, by the length of the sides, 4 centimeters. 6 times 4 equals 24, so that means the total perimeter must be 24. 24 what? Centimeters. That's better. Oops. And this formula works for any regular polygon, no matter how many sides there are. If the sides are all the same length, you can just multiply the number of sides by the side length, and you have the perimeter. Okay, let's try one more example. This polygon also has 6 sides, but it's not a regular polygon. The sides are different lengths, and this one's really tricky because they only show us the length of 4 of the sides. The other 2 are missing. So how can we figure them out? Problems like this come up all the time in math. Problems where you aren't quite given all the information. When you have this kind of problem, the key is to use what you do know to figure out what you don't know. Here's what I mean. Look closely at the 2 vertical sides that we do know the lengths of, 4 inches and 6 inches. Now, imagine that those 2 vertical sides could be moved straight across to the other side, the side that we don't know the length of. By doing that, you can see that the missing length would just be the combination of the 2 vertical lengths that we do know, 4 inches and 6 inches. And since 4 plus 6 equals 10, the missing vertical side must be 10 inches long. Notice that we can do the same thing for the horizontal sides that we do know. If we imagine those moving down to the side that we don't know, we see that its length must be equal to the combination of those 2 lengths. 10 inches plus 5 inches equals 15 inches. There, we've used the lengths that we did know to figure out the lengths that we didn't know. And now that we know the lengths of all the sides, we can just add them all up to get the perimeter. 4 plus 5 plus 6 equals 15, and then 15 plus 15 equals 30. 30 plus 10 equals 40. And last of all, 40 plus 10 equals 50. So, the sum of all the sides is 50 inches. And that's the perimeter of this shape. And that's the end of this lesson. We've learned that perimeter is the distance or length around a geometric shape. And we've learned how to calculate it for any polygon. You just add up the lengths of all the sides, and the total length is the perimeter. Oh, and don't forget your units. Also, don't forget that to get good at math takes practice. Thanks for watching Math Antics, and I'll see you next time.
Hello, and welcome to 5-Minute Math. Today we are looking at the 3rd grade concept of representing addition and subtraction problems. This is standard 3.59 in the great state of Texas, and we're using item number 30 off the 2018 released STAR test. If you have not done so already, please go ahead and take a moment to pause the video, See if you can work this problem out on your own, and then unpause it. We will look at our answers together. So this looks like a fairly complex problem. If you look at the answer selections, F, G, H, and J, they don't have regular equations, but they do have these strip diagrams. So let's just go ahead and label these. You might have heard of them before as part-part wholes, and that's fine. Part-part whole is a type of a strip diagram. There are other types of strip diagrams that are not necessarily part-part wholes, so either word works here. So we need to have a picture, a representation of our problem situation up here. So let's see if we can figure this one out. I'll write an equation first, and then we're going to match that to the correct strip diagram. There are a total of 294 restaurants. So when they give you this total right here, I'm just going to go ahead and put a equals 294. Because when they use this word total, that lets you know that that's going to be on one side of the equation. Remember, the equation needs to balance out. We need to pretend like our equation is like a balance, right? And so whatever's on this side, put a little box here, needs to equal everything that's over on this side, even if it looks a little bit bigger, because we're going to have some addition, subtraction, multiplication, division. But we need to balance it out. So of these restaurants, we've got 196 on the highway, 49 downtown, and then the rest. So there's my unknown. So I've got 294 restaurants, and it seems like we're just going to put 196. I can put that kind of in a box here. We're going to put 49 in a box here. And then the rest. So the rest is going to be my unknown. So I'm just going to put a little question mark here. So if I wanted to balance these two out, 196, it looks like we're going to have some addition signs here. So I can write this as a number sentence, 196 along the highway, plus 49 downtown, plus my question mark. Those are the ones on the shopping malls. All of that equals 294. So that's an equation to represent this problem. If we're wanting to find the number of restaurants in the city that are shopping malls, we can start with this, and we can use some different equations that use inverse operations, fact families. But we are looking at strip diagrams. So in a strip diagram, this is the number one thing we need to remember. When we're looking at a strip diagram, the whole or the total, if you ever get a whole or total, if that's given to you, and one of the unknowns is actually a part, the whole always goes up on top. That's how we do a strip diagram. So we're going to put this right here. So that represents everything, and then underneath it, we already know we've got three chunks. Sometimes they try to make them proportional. Sometimes they don't. I'm not going to worry about it this time. I'm just going to say 196, 49, and then question mark. So when I draw it like this, I don't have to include the plus signs, because the strip diagram shows you that when you connect these connecting bars are automatically plus signs. And so when you're looking at that, you see there's only one answer selection that actually has the whole total up on top, 294. And so they did make it proportional. They made that 196 much larger than the 49, which makes sense. So our answer is going to be G. Now, why is our answer G and not F, H, or J? Let's take a look at those. Look at what F, H, and J do. First off, F, H, and J all put your total down as one of the parts. They put the whole down with one of the parts. And if you add 294, 196, and 49 in F, or 294, 49, or 294, 196, take a look at these two. 294 and 196, they're way bigger than 49. That doesn't make any sense. 294 plus 49, already larger than 196. That doesn't make any sense. And then all of these three, we don't know what they're going to add up to, but it's going to be much larger than 294. And we already know that 294 is our total. So our answer is G.
Okay, we're going to work on a guided practice problem here. Follow along as I read. The chart shows the number of minutes Mia spent taking care of her dog this week. And you have a table right here, the activities that they did and the number of minutes that it took. And what we're trying to find out is how many more minutes did Mia spend playing with her dogs than she did walking and grooming her dogs. So I'm going to use cubes to pick out the important information here. I'm going to circle the important information. I'm going to go down here in the question because it asks pretty specific. So I just want to pick out the stuff that's important. So it's asking about the time that she spent playing with her dog and the time she spent walking and grooming her dog. So it looks like the walking is 210 minutes, the grooming is 120 minutes, and the playing was 420 minutes. So that looks like all the information that's important to me to solve the problem. I didn't need to know about feeding because it didn't ask anything about feeding. But I'll go ahead and underline the question. We read it, but I'm going to pay real close attention. It says, how many more minutes did Mia spend playing with her dog than she did walking and grooming her dog? Box in some operational clues. And I see how many more. That's right there in my question. That sounds like I'm going to have to subtract some. I'm going to have to do some subtracting. And so we're going to start to solve. We're going to solve this a few different ways. So first way we're going to use some mental math to solve it, because these are some nice round numbers, and they seem like they go together real well. So let's go ahead and try to do some mental math and solve this. So the first thing I would do is I'm going to start with my playing with the dog, which was 420, and I see the grooming was 120. That seems like a pretty easy math problem. What is 420 minus 120? Yep, that's correct. That is 300. So we went ahead and we figured out that if we took away the grooming time, that's 300 minutes. Now we need to take away the walking time. So I would go ahead, the next thing I would do is I would take 300 minus 200. What is 300 minus 200? Yep, 300 minus 200 is 100. So we're to 100 minutes. Okay, and how much time do we have left that we haven't used yet? Yep, we have 10 minutes left that we haven't used. So what is 100 minus 10? Yeah, that's right. 100 minus 10 is 90. So it looks like using mental math that we figured out that took her 90 minutes to walk her dog. Or no, I'm sorry. It took her 90 minutes. She spent 90 more minutes playing with her dog than she did walking her dog and grooming her dog. So I'm going to show you another way. Another way that makes sense to do this problem is to make a model. And we're going to kind of compare two different types of models. Okay, I'm going to do a part whole strip diagram here. So the walking her dog was a 420, and we'll say the walking her dog was a 210, and the grooming her dog was 120. And this is the part we was trying to figure out right there. Okay, I can also do a number line. Okay, a number line and strip diagrams are really pretty similar, in my opinion. So if I took a number line right there, and this would be 420 right here, and then I jump back, went back 210, and then went back another 120. That would put me at the point where that tells how many more minutes she spent playing with her dog, which was 90. And this part right in here would be 90. And we already did that using our mental math. But we'll go ahead and still go through and do a computation. Okay, if we're solving this problem using just regular computations, what would be the first thing we would do? Yeah, the first thing we would do is we would add together the walking and grooming time. So we would add together the 200 and then 120. We would add that together. So what is 210 plus 120? Yep, that's correct. That would be 330 minutes that they spent walking and grooming the dog. What would I do next? Yeah, that's right. I would take my 420, which is how much time she spent playing with her dogs, and subtract the 330. And that would tell me how much more time. So what is 420 minus 330? Yep, well, let's check it out real quick. 0 minus 0 is 0. 3 from 2, I cannot take 3 from 2, so I have to regroup. I'll take one of my hundreds and I'll move that to the tens place. And that gives me 12 tens or 120. And 3 from 12 or 30 from 120 is 90. So we did it a few different ways here. We actually used mental math to do it. We used a number line to work it out. We used a strip diagram. And we used a regular, just plain computations. We could have did it one other way. We could have subtracted twice, but I kind of ran out of space here. So the answer that we came up with was F, which was 90 minutes. If we look at some of our other answer choices right here, I have 330, and that would be the sum of the time that she spent walking and grooming her dog, which is not the correct amount. And 210 was the amount of time that she spent walking her dog, and 420 was the total amount of time that she spent playing with her dog. But 90 was the right answer. Okay, it's time to complete your independent practice. Please complete your Schoology assignment. It will be right after this video, and I'll have something there for you to print out, so you can print it out and work it on paper. But make sure you go ahead and do the blue puzzle piece, which is 3.5A, exit ticket, problem solving with today's date on it. And take your time, do your best. This is what we're using to assess whether you understand the skill or not. And if you do have any questions, though, please email your teacher or send them a message in Schoology. And remember, take your time, do your very best.